base thermodynamics rules that apply to closed space. Now, why doesn't it? Well, it can't, because it's a set of measurements in within, for example, a portion of closed space that we have a measurement for anti-de Sitter space, in which that we have a geometry and in which with a measurable degrees of freedom, whether that be a portion of the boundary of a black hole in which we can relate to the assumption of the assumed parameter between an event horizon, right, in which we can measure that, right? And now the control algorithm in which that expresses it through thermodynamic anomalies, right? That they're trying to say that, like, because of this section, because we can agree that within this closed space, that because over here it enacted as a way of a fluid, or by a certain way, that this part here is more measurable than over here because this is irrelevant, right? That's my take on it.
The answer to the question of why don't we see the non-locality all the time is precisely that we don't do exponentially complicated.
Because if you're expressing observable influence based on pattern, and you're trying to say that due to boundary, right? This is just say that this is a boundary, and that due to this boundary, that point from point C to D are unobservable based on a boundary, that there's no excuse for this behavior isn't relevant because A plus B equals regardless, right? A plus B equals A plus B, right? Like, that will always be the found on it. From this point, regardless, as I've expressed, whether A plus B equals A plus B equals A plus B, there will be at some point that A plus B equals will equal 0, right? Okay, go on.
Things.
I see.
And so there's this veil of complexity which is hiding the radical non-locality, which is necessary to solve Hawking's paradox.
I see. But let me ask you one question just along those lines again, for the benefit of people that perhaps have worked a little bit on this. You know, you teach quantum field theory, I teach quantum field theory. You know, when we teach effective field theory, there's a natural expansion that we can teach our students, and we can sort of directly see in that framework the limitations of the framework.
I always have notes.
You know, you're saying sufficiently low energies is one particular. Is there a way that I can see this complexity barrier from a similar kind of thinking?
Yeah. The way is that if you try to go past it, you